as we normally do, as we get into the Pythagorean theorem here, we get into something a little bit different and see if we can throw a few twists in here on the Pythagorean theorem to make it a little more interesting than just staring at triangles here. So, a little bit of background on it. Again, just to review to make sure we're good. So, we kind of can see here the Pythagorean theorem. Pythagoras came up with it. But the theorem part again, theorems show up not just in math class. You can start to see some theorems in other areas too. So we can demonstrate it to be true by accepted mathematical operations and arguments. In other words, you can prove it. Okay? That's what you're always going to have if you had a theorem with these. So the two sides of a triangle that form the right angle, because these are all going to be right triangles, are our legs. Works a little bit differently than the ones we have, but that's what we call them. And then the side opposite the right angle, the one side that's remaining besides our legs, is your hypotenuse. So we got legs and we got a hypotenuse. And so the hypotenuse is always the longest side. So if you ever see a triangle and you're like, wait a minute, that's the side opposite the right angle, but that's not the longest side. Somebody did something wrong somewhere, because that is always how that's going to work. The two legs are always shorter than the hypotenuse. I didn't put that on the end of this, should have. And so those bits of information are going to help us to see that the Pythagorean theorem tells us that in a right triangle, oops, almost wrote the wrong word in there. The sum of the squares, again, sum being plus, of the squares of the lengths of the legs is equivalent to the square of the length of the hypotenuse. In other words, a squared plus b squared equals c squared. The sum of my leg squares equals the square of the hypotenuse. Okay. And just for reference, it doesn't matter which leg is A and which one is B. They're interchangeable. So like if you had 3 and 5 as your legs, 3 squared plus 5 squared plus 3 squared, it's going to be the same thing. So again, A and B will always be our legs. C will always be our hypotenuse. You'd be surprised at the amount of stuff with Pythagorean theorem and some of its kind of offshoots show up on testing at all levels, just to kind of see, because it's kind of a universal theorem once you hit algebra that we're going to run into. And when I label stuff, I never write out whole words. I just kind of do that. So that can be helpful when you're starting to look at these so we can get things into the right order. So, for instance, and we'll take a couple different views, looks at this, because one of the cool things about math is that as you're working your way along... Gotcha. All right, thank you. So, when you're looking for the length of the missing side, there's a couple of ways that you can roll with those things sometimes. So, find the length of the missing side. Here's my legs. I'm missing my hypotenuse. Now, maybe we even want to go to the extent of labeling these A, B, and C, because that's more of what's looking like in our equation anyway. So we do 20 squared plus 15 squared equals C squared. That's going to be our hypotenuse. Even Hardy is going to the calculator on this. This is out of my realm this early in the morning.
I woke up late. I didn't use my breakfast this morning.
Well, that's not good. That's not good. There's lots of things that can get us off to interesting starts here. I am just lacking of sleep today. So, and here's the part I got to keep in mind, though. When I get to here, I'm not done. That's not my answer, the 625. That wouldn't make much sense anyway. 15, 20, and this side's 625. That'd be kind of wild. Square root that sucker. So if it's been a while on the square root on these, second and x squared, you see the little square root there in light blue. 25 is much more reasonable. And then this is more the bigger part. Before I even did that, I should have known that this value is going to be larger than 20 at least. Because it's got to be the longest side if it's the hypotenuse. And it is, and so I feel good about it. Now, when I get here, you actually have options. So maybe you're like, all right, so A, B, C. If I'm following this, if I go right in order, okay, I'd have this. So let's see what we got here. 99 squared is not one I know off the top of my head. 101 is not either. So this time, I can't just square root right away, because this time b squared is not by itself yet. So, get that 9801 out of there. And all of a sudden, this is going to end up really nice. And again, I'm just double checking. I may not be able to get an approximation of what exactly my answer should be, but it definitely should be less than 101, and it is. Okay? And that's kind of how that rolls. Now, some of you may have been taught at one time. I'll do this on a sticky note so you can kind of see what I'm up to here. Sometimes people have been taught if you have the hypotenuse, so instead of a squared plus b squared equals c squared, if you're missing a leg, yep, go right then. We can go ahead and just do the subtracting instead, so I don't have to do the extra step later. You don't have to do it this way. But in this case, that just would have been, so I'd have done it right away. 101 squared minus 99 squared. Whoa, got to type it in right, Hardy, for it to work. I think I should just know what I'm doing, and I shouldn't even have to type it in, it just knows. And so I end up basically in the same spot. I know it's a squared and b squared, but we see they're interchangeable. Take my square root. If you just like going straight with a squared, b squared, and c squared every time, though, it's fine. I mean, it was one step. So it's nothing going to be too bad. So here's kind of what we're going to do. Because you're like, dang, that's the end of the notes. Okay. Keep these handy, because again, we need them for the quiz. So a couple of things to keep track of. Okay, first thing that we're going to be working on, this goes with the notes from yesterday. We picked this up off the back table, the one you brought in. So again, all we're doing with these, actually let's do the first one. Lala makes $15 for babysitting plus an additional $6 per hour. So I look and I'm like, all right, she gets $15 no matter what, and an additional $6 per hour. So there's the per hour. That's the one that, depending on how many hours I work, I get more money. So I got to have the X on that one. But I'm going to get $15 no matter what. So I look and I'm like, if she wants to work at least 7, so at least 7 or maybe more, greater than, how much will she earn? Okay, this gets me my regular equation. But what I want to do now is, that is going to go in for the number of hours. So, I'm going to replace the x with 7. And so here's what that's actually telling me. I'm being given 2 bits of information to be able to make my graph here. Okay? This actually tells me, you know, that's how much she'd earn at a minimum if she worked 7 hours. She might work more. We don't know. But if I wanted to look at the graph of this, of what options she had, I'd go back in and I'd be like, okay, so here, my intercept is at 15, okay? When my y-intercept occurs, that occurs when x equals 0. So I got 1 point in here. Now over here, this is going to get a little more interesting because this is really going to be close. Here, my x value is 7. My y value is 57. So let's see. 50, that'd be 60. So we're going to be up here. It's or equal to, which means it's going to be a solid line. And greater than tells us we're going to be shading above. That kind of lets you get a visual of, okay, depending on how many hours I'm working, I'm going to be making at least this much money. And then we'll kind of see as we go. Do I have to have the graphs to get the answer? No. But again, it gives us more information. So at the very least on these, we want to make sure that we get the equation set up. Okay. So that's part, and again, I've got an answer key for this up front. I got to look in a minute and see if it's still online, but we'll see. So that's part 1. Then the rest of what we're going to be playing with for today, find the lengths of the missing sides here. There we go. But notice, I'm going to challenge you a little bit. On 4 and 6, we got to go back to some of our other shapes and look to see. So just as an FYI, so let's say, like we're looking back here at this one, our congruent marks, I mean, those are all 45. I'm trying to find the missing side, and then I can do the area. If you need a reminder on any of the area formulas, let me know. And then down here to find the perimeter, I've actually got 2 different triangles I'm working with. Let me just kind of outline those here in the red. So I'm going to have to do 2 problems with the Pythagorean theorem to find out my 2x values. Then I can find out how far is it all the way around the outside. So we can use some unknown information to find some other things. No. So that shouldn't be too bad, I don't think. But again, got a key to check as we go if we need it. And I'll put this one back up when I go to freeze frame in a sec. The last piece of today, like I said, this is kind of the start of the review already because I'm kind of hitting on a few different things. So we did the inequalities, we did this. The last piece today of what we're doing is going to be the error analysis right after, and you'll see we've got a couple of Pythagorean theorems that we're playing with. So you've got to look in knowing what you know about finding the sides and see if they're doing the work correctly or what the heck is going on. Those, where they need to be fixed. Those are the ones that I do not give answers for, but if you get stuck, let me know, and I can jump in and help there